circuit 2 of the lab looks like this. Actually, it doesn't. Looks like, whoops. Okay, I'm having trouble here, but it looks exactly like your first circuit, except there's resistors down below both transistors. The calculation to find, so remember that because with BJTs, the voltage from here to here is always approximately VBE on. That means the voltage from here to here is also VBE on, because this node is shorted to this node. And that means that for whatever current you've decided you want to have go through your biasing circuitry and therefore your mirror, that the rest of the voltage has to be dropped across these resistors. So what has to happen here is whatever your supply voltage is minus your VBE on, that has to be what the rest of the voltage, so the voltage from here to here and the voltage across this bottom resistor, those two voltages, the sum of those two voltages have to eat up the rest of the voltage that isn't dropped across the transistor, which is VBE on. So that it has to equal I R1 plus R2. So now for, this is for whatever current you've decided you're targeting, and that's for this lab, it's 1 milliamp or 0.1 milliamps. That has to, that current across these two resistors has to drop the remaining voltage that isn't dropped across the transistor, which is VB on. I think I already said that a couple times, but let's go back to that. So the way to calculate that, you can do some horribly complicated calculations, but the easiest way to do that is, let's call this R orig. So from the first part of the lab, you had to calculate R bias. Yeah, let's call it R bias because that's what is in the handout. So you had to calculate R bias, and what you know about this is you're still dropping VBE on across here. So you have VB on across here, but this has a wire shorting it to this node. So you have VB on across here. And so in this case, let's look at the equation for this circuit over here for R bias. And what you have there is VCC minus VBE on equals your I. Let's say you're targeting the same I in both of these circuits, I times R bias. So looking at that, what that tells you is that if you look at these two equations, means that this equation right here has to equal that equation right there. So let's write this up again. You have I times R1 plus R2 equals I times R bias. You can get rid of the i's, and now you know that R1 plus R2 equals R bias. So if you pick a value for R2, You can see from this equation, if you have a value for R2 and you know R bias, you can find R1. And from your calculations so far in the pre-lab, hopefully finding R bias is friendly. And then the pre-lab questions kind of walk you through how to find R2. But yeah, so once you find R bias and once you find R2, then you can find your R1. And again, when I labeled these up here, I labeled this top resistor, which used to be R bias, R1, and the bottom resistor, R2, just to separate it from this picture. In the lab handout, I think I still call this R bias. But just to make the math clear, I renamed that R1 and R2. Okay. So find R bias, because that's a straightforward calculation. Then find R2, and then define the size of this resistor up top. Subtract R2 from R bias, and you've got your R1.